This video is for Math 1001 Quantitative Reasoning. It covers topics in Unit 1, specifically the topic of proportions. This can be found in Section 6.2 of your ebook. We'll begin by defining a proportion. A proportion is an equation in which two ratios are stated to be equal. Example 1. Are the following proportions true or false? Which means, are the following proportions showing equal ratios? We can do this using cross multiplication. So, what we'll do is use cross multiplication. We'll have 3 times 20. We're going to check to see, is that equal to 5 times 12? 3 times 20 is 60. 5 times 12 is also 60. So, yes, true. This is a true proportion. All right, let's look at the next one. Again, we can quickly check with cross multiplication. We have 5 times 5, and we want to see, is that equal to 3 times 7? 5 times 5 is 25. 3 times 7 is 21. That is not true. Therefore, this is false. This one is not a proportion. Let's move on to example 2. Now that we have determined what it means to be a proportion, we are going to solve some proportions, which means we are going to find x in each of these. Again, we can use cross multiplication to help. So I will do my cross multiplication. I have 3 times 28, and I want to set that equal to 12 times x. Okay, 3 times 28 is 84, equal to 12x. And to solve, I'll divide both by 12. The 12 over 12 will cancel. And 84 divided by 12, this tells me that x equals 7. Okay. For part B, we're going to do the same thing. So we have 4 times 25. Set that equal to 5 times x. This is 100 equals 5x. We'll divide both by 5. The 5's over here cancel each other out. And we get that 100 over 5, which is 20, equals x. So in that case, x equals 20. We can use proportions to solve real-world applications as well. So let's look now at examples 3 and 4. Example 3. At an ice cream store, about 2 out of every 3 people choose to include whipped cream on their milkshake. If the store sells 93 milkshakes in a day, how many people should you expect to choose whipped cream? So what we want to see is we want to set up a proportion that has the same ratio. 2 out of 3, what is that out of 93? So let's set up our proportion. 2 out of 3, that's how many people choose whipped cream. And the store sells 93 milkshakes total, and we want to know how many choose the whipped cream, so we'll put that x there. So notice, 2 choose whipped cream out of 3, x choose whipped cream out of 93. We have to make sure that we set them up the same pattern. So now I can solve using cross multiplication just like I did before. So I have 2 times 93 equals 3 times x. 2 times 93 is 186 equals 3x. I'm going to bring this up here so I have a little bit more room. And then I'll divide both sides by 3. And I get that x is equal to 62. So what does that mean? About 62 people will choose whipped cream. And we say about because in our original question it said it was about 2 out of every 3 people choose whipped cream. So if we sell 93, we should expect about 62 people to have whipped cream. Okay, let's look at example 4. A school has 550 students and 25 teachers. If the enrollment increases to 625 students, how many teachers will the school need if they want to keep the same student-teacher ratio? So let's look at the student-teacher ratio for now. It's 550 students and 25 teachers. We want to keep the same ratio, so we can set up a proportion. The enrollment is going to be 625 students, and we want to know how many teachers that corresponds to. So there's my proportion. I'm setting up 2 equal ratios. I'm going to rewrite this without all the variables in them, or all the 625 over x, and we'll solve using cross multiplication. 550x equals 25 times 625. This tells me that I'm going to come up here. 550x equals 15,625. Just multiply those out real quick on my calculator. Then I'll divide by 550, divide by 550. These cancel, and then I get x equals, and I don't get a nice whole number. I get 28.40909. Those 09s just keep repeating. So let's go back to the context of the problem. If I want to keep the same student-teacher ratio, I need 28.4 teachers. Well, that doesn't make very much sense. I can't have 0.4 of a teacher. So the idea here is to keep roughly the same student-teacher ratio. I can round this and say I need 28 teachers. And depending on the situation and what you're doing, maybe you'd want to round up, maybe you would want to round down, but we need roughly 28 or 29 teachers to keep about the same student-teacher ratio.